But the idea is that they're pulling answers from different universes simultaneously. They don't even completely understand how this is working. But the amount of power in computing is incomprehensible, and it's probably the biggest breakthrough technologically in human history by a long stretch. And it's all happening without most people even being aware of what the implications are.
Willow is not like any other chip we know. It's a quantum chip. In simpler words, it can solve a problem that none of our supercomputers can. And Google claims to have tested this chip.
Google says it has cracked a key challenge in quantum computing. The tech giant has unveiled a new quantum chip it claims can transform computing by offering speeds far beyond traditional systems.
What if the key to unlocking parallel universes was hidden inside a quantum chip? Google's latest quantum breakthrough, Willow, is pushing the limits of what we know about reality. Could quantum computers be tapping into alternate dimensions, or is it all just probability manipulation? The answer might redefine science itself. This revolutionary quantum processor has achieved something extraordinary, solving a complex problem in under 5 minutes. A task so challenging that even the fastest supercomputers on Earth would take an estimated 10 septillion years to complete. Yes, that's 10 followed by 25 zeros. Moreover, some researchers suggest that this breathtaking computational power might hint at a connection to parallel universes, where calculations could be unfolding across multiple realities at once. In this breakdown, we'll explore Willow's historic achievement, the multiverse hypothesis that has sparked intense debate, and why some experts remain skeptical about the broader implications. Understanding classical versus quantum computing. To fully appreciate Willow's accomplishment, it's essential to grasp the fundamental difference between classical and quantum computing. Classical computers process information using bits, which exist in one of two states, 0 or 1. In contrast, quantum computers utilize quantum bits or qubits that harness the principles of quantum mechanics. Qubits can exist in a state of superposition, meaning they can be both 0 and 1 simultaneously. Additionally, qubits can be entangled, a phenomenon where the state of one qubit is instantaneously linked to another, regardless of the distance between them. These unique properties allow quantum computers to process an astronomical number of possibilities at once, something classical systems simply cannot replicate. Willow's groundbreaking achievement. What makes Willow's achievement so groundbreaking is the specific problem it solved. The chip was tasked with generating outputs for a random distribution benchmark, which involved navigating incredibly complex and entangled quantum patterns. For classical computers, this task would have been nearly impossible, taking an unfathomable amount of time. Willow, however, completed it in under 5 minutes, marking a milestone in what scientists call quantum supremacy, the point at which a quantum computer outperforms even the most advanced classical systems. This isn't Google's first claim to quantum supremacy. Back in 2019, the company unveiled a 50-qubit chip that solved a computational problem in 200 seconds, a task Google argued would take classical supercomputers 10,000 years. IBM later challenged that assertion, suggesting the problem could be solved classically in days rather than millennia. With its 105 qubits, Willow represents a quantum leap forward, quite literally. Each additional qubit doubles the computational power of a quantum processor, making Willow exponentially more powerful than its predecessor. Error correction, techniques, and practical applications. Adding to the significance of Willow's success are its cutting-edge error correction techniques. Quantum systems are notoriously fragile. Even slight environmental disturbances can cause computational errors. Google's advances in stabilizing qubits and improving error correction make Willow not only faster, but more reliable, an essential step toward making quantum computers practical for real-world applications. So, What does this mean for the future? For now, Willow's achievement is largely theoretical. Solving the random distribution benchmark doesn't have immediate practical applications, but it showcases the transformative potential of quantum computing. In time, machines like Willow could revolutionize fields such as cryptography, drug discovery, material science, and climate modeling. The possibilities are vast, offering a tantalizing glimpse of what's to come. The multiverse hypothesis, a glimpse into parallel universes. However, there's another layer to Willow's achievement that has captured the imagination of scientists and philosophers alike: the possibility of parallel universes. This idea, which sounds like science fiction, is rooted in serious physics, specifically the multiverse hypothesis. Quantum mechanics tells us that particles can exist in multiple states simultaneously, a phenomenon known as superposition. Yet, when these particles are measured, they appear to collapse into a single state. This forms the foundation of the Copenhagen interpretation, the most widely accepted explanation of quantum mechanics. But what if those other states don't actually disappear? Physicist David Deutsch, a pioneer of quantum theory, proposed the many worlds interpretation, suggesting that every possible outcome of a quantum event exists in its own parallel universe. For instance, if you flip a coin, it might land heads in one universe and tails in another. Scaling this up to a quantum computer like Willow, the hypothesis suggests that when it performs a calculation, it might explore different solutions simultaneously across countless parallel universes. The final answer, then, would emerge in our universe as the product of collaboration across infinite realities. It's a mind-bending concept that, if true, could offer a profound explanation for the seemingly magical speed of quantum computation. Skepticism and ongoing debate. Of course, not everyone subscribes to the multiverse theory. Many physicists favor the Copenhagen interpretation, viewing quantum states as probabilities that collapse into a single outcome when observed, without the need to invoke parallel worlds. Whether Willow is tapping into alternate realities or simply exploiting the extraordinary properties of quantum mechanics, its performance is undeniably impressive. Still, skepticism remains. Critics argue that while Willow's achievement is groundbreaking, it remains largely theoretical without immediate real-world applications. Physicist Sabine Hossenfelder has compared it to building the fastest race car and testing it on an empty track. Exciting, but not yet transformative. The challenge of scalability. Another major hurdle is scalability. While 105 qubits marks significant progress, practical quantum computing will require millions of qubits functioning reliably and without errors. Even though Google has made strides in error correction, the field still faces significant challenges before quantum computing becomes truly useful. Despite these obstacles, Willow's success is a crucial milestone. Every theoretical advancement brings us closer to an era where quantum computers could revolutionize fields like drug discovery, material science, and ultra-secure encryption. The potential impact is enormous. Willow isn't just a research achievement, it's a testament to human ingenuity and a preview of what's to come. To understand why Willow's success is significant, we need to revisit the principles of quantum mechanics, the foundation of quantum computing. Unlike classical bits, which are either 0 or 1, quantum bits, qubits, leverage superposition, meaning they can exist in multiple states at once. Additionally, entanglement links qubits, so that the state of one instantly affects another, no matter the distance. These properties allow quantum computers to perform calculations at an unprecedented scale. Are quantum computers tapping into parallel universes? The idea of parallel universes comes from the many worlds interpretation, MWI, of quantum mechanics. This theory suggests that every quantum event results in multiple possible outcomes, each unfolding in its own branch of reality. Some have speculated that quantum computers, by leveraging superposition and entanglement, are simultaneously performing calculations across multiple parallel worlds. However, this idea remains largely theoretical. While quantum mechanics allows for extraordinary computational power, it does not imply that we can directly access or interact with alternate realities, quantum simulations, and the multiverse. Even if quantum computers aren't literally accessing parallel universes, they might help us explore these concepts in new ways. Advanced quantum simulations could allow researchers to model systems with multiple possible outcomes, mimicking how a multiverse might behave. This could lead to deeper insights into the fundamental nature of reality. Another intriguing connection between quantum computing and physics is wormholes, hypothetical shortcuts through space-time that could link distant points in the universe or even separate universes. While purely speculative, the immense computational power required to model such structures could be within reach of future quantum computers. If Google's quantum chip advances further, it might help physicists simulate extreme conditions and test the feasibility of these theories, pushing the boundaries of science and technology. While we are still far from proving or disproving ideas like parallel universes or traversable wormholes, quantum computing is opening new doors in fundamental physics. Whether Willow and its successors are tapping into hidden dimensions or simply refining probability calculations, one thing is certain: the journey into quantum mechanics will be as captivating as the discoveries themselves. Quantum computing is rewriting the rules of reality. But how far can it go? Let us know your thoughts in the comments. Don't forget to like, subscribe, and hit the bell for more mind-blowing content.